Okay, a very good morning or good afternoon, 41. Okay, basically this chapter is on chapter 13, oxidation and reduction. Okay, so you have already looked at the slides and you fill in the blanks. So basically, this lesson I'll be taking you through the examples. Okay, so you have a better understanding of what to fill in. Okay, so basically to recap, okay, when it's oxidation, how to remember? Okay, in terms of the four ways, you can look at how oxidation has occurred. Okay, it's in terms of bowling, whereby it's gain of oxygen, loss of electrons or hydrogen. Okay, and for reduction it's logate, okay, loss of oxygen, gain of electron or hydrogen. Okay, so for oxidation I'm going to use the short form, okay, this one, the square bracket O. Okay, and for reduction will be the square bracket R. Okay, now oxidizing agent, okay, the short form will be OA, O dot A, reducing agent R dot A. Okay, and you learn the concept of redox reaction. Now, if you look at redox reaction, you can see the word red and ox. Okay, so basically what does the red and ox mean? This one means reduction, and this one means oxidation. And since they are in the same word, meaning they must take place at the same time. That's why your definition of a redox reaction is oxidation and reduction taking place at the same time. Okay, at the same time. Okay, Ken? Okay, now with that, okay, so we're going to move on. Okay, so now if there's reduction and oxidation taking place at the same time, that means there must be a substance oxidized and reduced at the same time. Okay, so if you look at page 1 at the bottom, you have a box. When you identify whether or not an oxidation, reduction or redox reaction has taken place, okay, you go in that sequence. You look at it in terms of gain or loss of oxygen or hydrogen first. If don't have, then look at it in terms of change in oxidation state. Okay, now if you look at page 2, okay, example 1, we're going to look. Okay, page 2, example 1. Okay, whereby we are looking at zinc. Okay, reacting with copper oxide to give you zinc oxide and copper. Okay, so now what you need to do is to match. So you're going to ask yourself, are you going to look at it in terms of oxygen or hydrogen? Okay, so if you look at it, there is no hydrogen at all. So we'll look at it in terms of oxygen. Okay, so how will we match? Okay, I want you to take a different colored pen. Okay, so zinc, we're going to look at it in terms of oxygen. So you notice you'll match it with zinc oxide. Okay. Okay, so if you look at it, zinc to zinc oxide, what happened? Okay, zinc has actually gained oxygen. Alright, so if you look at it in terms of gaining oxygen, so what happened to zinc? So therefore, zinc oxidized. Okay, so that's one. Next, you're going to match, okay, copper oxide. You will match with copper. Okay, so what happened to copper oxide? You'll notice that copper oxide has lost oxygen. So copper oxide lose oxygen. Okay, and based on the definition, when a substance loses oxygen, so therefore copper oxide reduced. Okay, Ken? Alright. Okay, maybe I write it the other way. So, okay, copper oxide. Okay, I hope you can see. Okay, I'll write it lower. copper oxide lose oxygen, therefore copper oxide reduced. Okay, so with that, if zinc is oxidized, okay, what reagent will it be? Okay, therefore zinc reducing agent. Okay, and because copper oxide is reduced, therefore copper oxide oxidizing agent. Okay, or is oxidizing agent. Okay, so that's why that is what you see in the blanks that you filled in. Okay.